Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study Math, Science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 20, Cylinder, Cone and Sphere. We'll be discussing the conversion and combination of solids with examples and solve questions from Exercise 20D and Exercise 20E. Hope you all are ready with your formulas and the pen and papers. Let's solve together. Let us first understand what does conversion of solids mean. Here you can see some figures. Here a cylinder is converted into a cone. 4 small spheres are converted into a big sphere. Then a sphere is converted into a cylinder. Here we have a cube. This cube is converted into 2 hemispheres. Okay, what happens in all these cases is the volume remains constant. For example, if you are taking a glass which is cylindrical in shape, okay, which is filled with water up to the rim. Okay, this glass is filled with water up to a rim. Now you take a bowl and fill this water into the bowl. Okay, and we see that this bowl, this hemispherical bowl gets completely filled with water. Okay, which means the volume of water inside the cylindrical glass is equal to the volume of water in this hemispherical bowl. The capacity of cylinder and the capacity of this hemispherical bowl are equal. Okay, this is how conversion of solids can be understood. Here when you take a cylinder, this is a metallic cylinder, it is melted and we are forming a cone. Okay, the metal used in this cylinder is equal to the amount or the quantity of metal that is used to make this cone. Yes, which means the volume of the cylinder will be equal to the volume of cone. In some cases, will be given the radius and the height of cylinder. Will be asked to find the height of cone when the radius of cone is given. In that cases, we can find the height of cone easily by comparing the volumes which are equal. Okay, here we have 4 spheres. For example, you get dairy milk chocolates. We take 4 pieces. Okay, this 4 pieces of the chocolate, we melt it and make a bigger piece. Which means we are not wasting any chocolate. In that case, the volume of all these 4 together taken will give the volume of this bigger cube which is formed. Okay, same here, we have 4 metallic spheres. These 4 metallic spheres when melted will form a bigger sphere. Okay, which means we'll be doing 4 into volume of one sphere will be equal to volume of the bigger sphere. In that case, they will be asking you to find either the radius of smaller sphere or the radius of bigger sphere. Okay, in case of spheres, you don't have any height. You have to find the radius or maybe the diameter. Now, when you have a sphere, we know the volume of sphere can be determined by the formula 4 by 3 pi r cube. Okay, this sphere is melted and converted into a cylinder. How to find cylinder's volume? It is pi r square h. Okay, now if the radius of sphere and the radius of cylinders are given and we are asked to find height, by comparing their volumes, we can find what the height is. Yes, let us take the radius of the cylinder as capital R. Okay, just for the comparison. We need to find height h. Since the volume of both these shapes are the same, we'll be having 4 by 3 pi r cube equal to pi capital R square h. Then how to find h? We can cancel this pi. H will be equal to 4 by 3 small r cube divided by capital R square. I am taking this R square to the opposite side. Okay, this is how you can find the height of the cylinder by comparing the volume of both these. Okay, now when it comes to a cube or a cuboid, you remember what the volume of cube and cuboid are? So, a cube will be having length, breadth and height same. Okay, when it comes to cuboid, they are different. So, length into breadth into height is the volume of a cuboid. A cube is a cuboid whose all sides are equal. Therefore, if you are taking one side as A cube will be the volume. Okay, this A cube volume, cube is melted and two hemispheres are formed, which means the volume of hemisphere, we know how to find the volume of hemisphere. Volume of hemisphere is 2 by 3 pi r cube. We have two hemispheres formed, 2 into 2 by 3 pi r cube. Okay, this will be equal to A cube, where A is the side of the cuboid. In case if we are asked to find what the side of the cube is, if the radius is known, we can easily determine, yes, or you are asked to find the radius of hemisphere when the side of cube is given. In that case, by substituting the value, you can find what the radius is. Okay, while solving problems, you will understand it better. Clear? Let us take an example. A metallic sphere of radius 10.5 cm is melted and then recast into small cones, each of radius 3.5 cm and height 3 cm. Find the number of cones thus formed. Here we are taking a metallic sphere. This metallic sphere of radius 10.5 cm is melted and cones are formed. Smaller cones are formed. We don't know the number of cones and we need to find the number of cones. Okay, we don't know how many cones are formed. Each of radius 3.5 centimeter and height 3 centimeter. Okay, height is 3 centimeter and radius is 3.5 centimeter. We need to find the number of cones. How to find number of cones in this case? We have said the dairy milk example. You remember? So 4 smaller cubes are taken and melted to form a bigger cube. In that case, 4 into volume of smaller cube will be equal to the volume of bigger cube. Same here, the volume of the sphere will be equal to, we don't know number of cones, we'll take it as n into the volume of smaller cones. Okay, let n be the number of cones. First we need volume of sphere, volume of metallic sphere, that is equal to 4 by 3 pi r cube. Here the radius is 10.5, therefore 4 by 3 pi 10.5 cube. Okay, next we need the volume of one cone will be equal to 1 by 3 pi r square h. This is a formula to find the volume of cone. Values are 1 by 3 pi r square 3.5 square and height is 3 centimeter into 3. Okay, we are having volume of sphere is equal to number of cones n into volume of one cone. Okay, then what is n? N will be equal to volume of sphere divided by volume of cone. Volume of sphere divided by volume of cone. Okay, therefore n will be equal to volume of sphere. Volume of sphere is 4 by 3 pi into 10.5 into 10.5 into 10.5 divided by volume of cone is 1 by 3 pi into 3.5 into 3.5 into 3. Okay, here 3 is there in the denominator of numerator and denominator of the denominator. Then pi can be cancelled. 10.5, 3.5, they can be cancelled. So in order to remove the decimals, we have to multiply the numerator and denominator with 1000. Here in the numerator there are 3 decimal points and in the denominator we have 2. Therefore, by multiplying the numerator and denominator with 1000, we will be getting 4 into 105, 105 into 105 divided by 35 into 35 into 30. Okay. Now, 35 into 3 is 105. So here we get a 3. 35 into 3. Again 105. Again we are getting a 3. 3 and 30 can be cancelled. We get 10. Okay, so 4 into 3 into 105 divided by 10. When you do the calculation, you will be getting 1260 divided by 10, and that is equal to 126. Okay, here we have determined n, which is the number of cones. So there is no unit, 126 cones. So 126 cones can be formed when a metallic sphere of radius 10.5 centimeter is melted. Okay, cones of radius 3.5 centimeter and height 3 centimeter. Clear how to find the number of cones? Next is the combination of solids. We have studied the conversion of solids. How we can compare the volumes when a cylinder is converted into a sphere, or a sphere is converted into cone. Cone is converted into a hemisphere. In that case, next is a combination of solids. Here you can see a cylinder plus 2 hemispheres. These hemispherical balls are kept at the top and bottom portion of the cylinder. Will be getting somewhat this shape. This is like the shape of a tablet. Okay, so to find the total volume of this shape which is formed, will be adding the volume of cylinder and 2 times the volume of hemispheres. Okay, so the volume of the solid which is formed here will be equal to volume of cylinder plus volume of hemisphere into 2. Why into 2? Here we have 2 hemispheres. Okay. Remember one thing. In this cases, these hemisphere can be fitted at the top and bottom of the cylinder when the radius are same. Okay. Even there are cases when there are different radius. You will be getting somewhat a different shape. You have a cylinder and 2 hemisphere of greater radius than the radius of cylinder are taken. Okay. Then how will the solid look like? The solid will be like somewhat this will be the shape of the solid which is formed. In that case, if you are asked to find the total surface area, how to find total surface area? Here, this portion and this portion will be fitted together. Yes, the top of the cylinder and bottom of the hemisphere formed will be fitted together. So you don't have to add these. Okay, they get cancelled and it becomes just a covering. So when you calculate the curved surface area of cylinder should be taken, curved surface area of hemisphere should be taken, and 2 times. Okay, so the total surface area will include this hemispherical curved surface area, this hemispherical curved surface area, and this cylindrical curved surface area. Okay, you don't need to add this pi r square, this pi r square, this pi r square, and this pi r square. Okay, because they get completely fitted. Next, if you have a cone and the hemisphere, how to find volume? Volume of cone plus the volume of the hemisphere. When it comes to curved surface area, to find curved surface area or the total surface area of the solid which is formed, you will be including the curved surface area of cone and the curved surface area of the hemisphere. You don't need to take the total surface area because this base of the hemisphere and base of the cone will be fitted together. So when you take the total surface area, for example, if you are painting this figure, you don't need to paint this bottom portion of the cone and the bottom portion of the hemisphere, right? So to paint this complete, the total surface area is taken and the total surface area will be including the curved surface area of cone and the curved surface area of hemisphere. Okay. Next, you have a cube and a hemisphere. So when this cube and hemisphere are combined, you will be getting somewhat a figure like this. Okay, the solid will look like this. Here, when the hemisphere is completely fitted on top of the face of cuboid or the cube, you will be having the hemisphere like this, which means the side of the side of cube will be equal to diameter of base of hemisphere. Okay, if this is how it is fit. You can see this, right? This is the diameter of base of the hemisphere. It will be equal to the side of cube. Now, if you take an ice cream cone, okay, so this is an ice cream cone. You need to find the total volume of ice cream that is inside this cone. Okay, how to find? Here ice cream is filled in this conical portion. Also ice cream is filled in this hemispherical portion. So the total volume will be volume of the cone plus volume of hemisphere. Okay, if you are taking ice cream in a bowl, you have a hemispherical bowl. Okay, and the ice cream is filled in this way. We have two hemispheres, maybe of different radius. If the ice cream is not completely filled, it is somewhat like this, or ice cream is kept in a conical shape. So depending on the shape in which the solid looks like, you will have to calculate the volume. Okay, the capacity which can be held in each can be calculated in this way. Understood? Second example, a toy is in the form of a cone mounted on a hemisphere with the same radius. The diameter of the base of the conical portion is 12 cm and its height is 8 cm. Determine the surface area and volume of the toy. So let us make a rough figure. We have a hemisphere at the base and a conical portion above it. Okay, given that the radius of the hemisphere and that of cone are the same, the diameter of the base of the conical portion is 12 cm. If the diameter is 12 cm, radius will be half of 12 cm, which is 6 cm. 6 cm is the radius. Okay. And height is given, which is 8 cm. Height is 8 cm. Therefore, 6 cm will be the radius of cone as well as the radius of the hemisphere. We need to determine the surface area and the volume of the toy. Surface area means the total surface area, which will be including the curved surface area of cone and the curved surface area of the hemisphere. Total surface area is equal to curved surface area of cone plus curved surface area of hemisphere. So what is the formula to find curved surface area of a cone? That is equal to pi r L plus curved surface area of hemisphere is 2 pi r square. Now here it is given the radius and the height of the cone. We need to find the slant height. Here have slant height L. Pi r L. L is the slant height. How to find slant height L? We have L square is equal to h square plus r square. Put the values. L square will be equal to h square is 8 square and radius is 6, therefore 6 square. L square is equal to 8 square 64 plus 6 square 36. Okay, 64 plus 36 is 100. L square is equal to 100, which implies L will be the root of 100 and that is 10. 10 centimeter is your slant height. Okay, now put the value. Total surface area will be equal to pi r L. Pi into 6 into 10 plus 2 pi r square. 2 into pi into r square. R square is 6 square. Okay. From this we can take pi r outside. That is pi into 6 can be taken out. The remaining will be having 10 plus 2 into 6. 10 plus 2 into 6. Okay. Now here it is given that we have to take pi value 3.14. If it is given in the question, you have to use this value. Okay. So 3.14 into 6, 10 plus 2 into 6 is 12. Okay. 3.14 into 6 into 12 plus 10, 22. Okay. That is equal to 3.14 into 132. Okay, 132 you will be getting. When you do the calculation, the final answer will be equal to 414.48 and the unit is centimeter square. So this is the required total surface area. Clear? 414.48 centimeter square. Okay, next we need to find the volume of the toy. Volume of the toy includes the volume of cone plus the volume of the hemisphere. Volume of toy will be equal to volume of cone plus the volume of hemisphere. What is the volume of cone? Volume of cone is equal to 1 by 3 pi r square h plus volume of hemisphere. Hemisphere volume is 2 by 3 pi r cube. Common terms can be taken out since here the radius is same. Okay, if radius is different, you cannot take r outside. 1 by 3 pi r square is common. Then you have a h from here and 2r from here. Put the values 1 by 3 into 3.14 into radius square 6 square into h plus 2r. H is equal to 10. So 10 is the slant height. H is equal to 8. Okay. 8 plus 2 into r square. Radius is 6. 6. When you do this calculation, you will be getting the final answer 753.6 centimeter cube. So this is a volume. So the unit will be centimeter cube. Okay, we have determined the total surface area of toy and the volume of the toy. Clear? So remember this thing. If in the question pi value is given, you should use this value only. You cannot use the 22 divided by 7 value. Okay, next example 3. From a solid wooden cylinder of height 28 centimeter and diameter 6 centimeter, 2 conical cavities are hollowed out. The diameters of the cones are also of 6 centimeter and height 10.5 centimeter. Taking pi is equal to 22 by 7, find the volume. Okay, here we have a cylinder. From this cylinder, 2 cones are hollowed out. Okay, this is the cylinder. This is your first cone and this is your second cone. These cones are hollowed out from the cylinder. Given height of the cylinder is equal to 28 centimeter. Diameter is 6 centimeter. If diameter is 6 centimeter, then radius will be equal to 3 centimeter. Same is the radius of the cone. What else is given? Height is given. Height of the cone is given, which is 10.5 centimeter. We need to find the volume. Volume of remaining solid. So this is the volume of remaining solid. The shaded portion will be the volume of remaining solid. Consider a cylinder from which top portion and bottom portion we are removing a conical parts. Okay, then this is how the solid looks like. Therefore, we have volume of remaining solid equal to the total volume of cylinder minus 2 times volume of cones. Why 2 times? Because from the bottom and the top portion cones are hollowed out which are of equal size. Okay, minus 2 times volume of cone. Now what is the volume of cylinder? Volume of cylinder we have pi r square h. Yes, and the volume of cone. Volume of cone is equal to 1 by 3 pi r square h. Here the radius is same but the height is different. Let us take capital H as the height of the cylinder and small h as the height of the cone. Okay, therefore we will be having pi r square capital H minus 2 into pi r square small h. Okay, pi r square is common. This will be equal to pi r square capital H minus 2 into 1 by 3 pi r square small h. Okay, pi r square is common. Taking out pi r square, we have capital H minus 2 by 3 into small h. Okay, 2 by 3 into small h. Now put the values. 22 divided by 7 here. We are asked to take pi value 22 by 7 into r square is 3 into 3 into capital H is equal to 28 minus 2 by 3 small h. Small h value is 10.5. Okay, that is equal to 22 divided by 7 into 3 into 3 into 3 is taken as the LCM. Here we will be having 84 minus 2 into 10.5 is 21. That is equal to 22 by 7 into 3 into 3 into 84 minus 21 is 63 divided by 3. 3 gets cancelled. 7, 63. You get 9 here. When you do the calculation, that is 22 into 3 into 9, the final answer will be equal to 594 centimeter cube. So this is the volume of the remaining solid. Volume of remaining solid is equal to 594 centimeter cube. Never forget to put the units. Unit is very important. Clear? Let us now solve problems from exercise 20D. Here we have the first problem, question 2 of exercise 20D. A hollow sphere of internal and external diameters 4 cm and 8 cm respectively is melted into a cone of base diameter 8 cm. Find the height of the cone. Here we are having a hollow sphere. This hollow sphere is melted and we get a cone. Okay. For the hollow sphere, the external and internal diameters are given. External diameter is 8 cm. If external diameter is 8 cm, what is the external radius? External radius will be half of 8 cm, which is 4 cm. External radius 4 cm. Okay. What about internal radius? Here internal diameter is 4 cm. Therefore, internal radius will be half of 4 cm, which is 2 cm. 2 cm. Okay. Now, this is melted. The metal in this hollow sphere is melted and you are forming a cone. Cone's base diameter is given, which is again 8 cm. Therefore, base radius will be 4 cm. Okay. We need to find the height of cone. Clear? We have external radius, capital R is equal to 4 cm. Internal radius, small r is equal to 2 cm. Then, what is the volume of hollow sphere? We have volume of hollow sphere. What is the formula? Equal to 4 by 3 pi capital R cube minus small r cube, where capital R is external radius and small r is internal radius. Put the values. 4 by 3 pi capital R cube 4 cube minus small r cube 2 cube equal to 4 by 3 pi. What is 4 cube? 4 into 4 into 4 equal to 64 minus 2 cube is 8. We get 4 by 3 pi into 64 minus 8 is equal to 56. Okay, so this is the volume of hollow sphere. Now, this is converted into a cone, which means the volume of cone will be equal to the volume of hollow sphere. Okay, let us find the volume of the cone. Let H be the height of cone. We don't know what the height is and we need to find the height. We know one thing, that is volume of hollow sphere is equal to volume of cone. What is the volume of cone? How to find volume of cone? We have formula 1 by 3 pi r square h. 1 by 3 pi r square h. Okay, here 1 by 3 pi r square. The value of r is 4. 4 square h equal to 1 by 3 pi. 4 square into 16 into h. Okay, now the volume of hollow sphere is 4 by 3 pi into 56 and the volume of cone is 1 by 3 pi into 16 into h. We can compare this and find the value of h. Okay, we know that the volume of hollow sphere is equal to volume of cone. Therefore, 4 by 3 pi into 56 is equal to 1 by 3 pi into 16 into h. Okay, 3 gets cancelled. We can cancel 4 and 16. 4 4s are 16. Okay, therefore we be having pi and pi getting cancelled. H is equal to 56 divided by 4 equal to 56 by 4 is 14. 14 centimeter is the required height of the cone which is formed when a hollow sphere is melted. Okay, understood this? So here you don't need to do all the calculation. Don't put the values of pi 22 divided by 7 and find the correct volume. Better keep it as it is so that you can cancel this pi. Then whatever is there to cancel, you can cancel easily. Okay, better than finding the actual value, you can keep it as it is and then the calculation will become easier. Okay, problem number 2, question 4 of exercise 20D. Total volume of 3 identical cones is the same as that of bigger cone whose height is 9 cm and diameter 40 cm. Find the radius of the base of each smaller cone if the height of each is 108 cm. Here, the volume of a bigger cone is equal to volume of 3 smaller cones. Okay. Given that the bigger cone has a height of 9 cm. This height is 9 cm and diameter is 40 cm. If diameter is equal to 40 cm, then radius is 20 cm. What about smaller cones? There are 3 smaller cones and each cone has a height of 108 cm. We need to find the radius of base. Okay, we have volume of bigger cone is equal to 3 into volume of smaller cone. Okay, what is the volume of bigger cone? Volume of bigger cone is equal to 1 by 3 pi r square h. Put the values 1 by 3 pi r square. Here the radius is equal to 20 cm. 20 square into height. Height is 9. Okay. Don't simplify this. Keep it like this so that you can cancel. Next, volume of smaller cones is equal to 1 by 3 pi r square h. Put the values 1 by 3 pi r square. We need to find radius. Then height. Height is given which is 108 cm into 108. Okay. We have volume of bigger cone is equal to 3 into volume of smaller cone. Putting the values 1 by 3 pi 20 square into 9 is equal to 3 into 1 by 3 pi r square h. Here h is 108. Okay. 1 by 3 can be cancelled. Pi and pi can be cancelled. Then we have r square is equal to here 20 square into 9 divided by. What are the terms that is with r square? We have 3 and 108. It becomes division. 3 into 108. 3 3s are 9. Then 3 into 36 is 108. Okay. So we have r square is equal to 20 square divided by. What about 36? 36 is 6 square. 6 square. Then what is r? R will be equal to 20 divided by 6. Okay. This is 20 by 6 whole square. Therefore, radius will be 20 by 6 equal to 10 by 3. You can write like this, or this can be written as 3 1 by 3 or 3.33 centimeters. Clear? This is how we can find the radius of smaller cone. There are 3 smaller cones of radius 3.33 centimeter and height 108 centimeters. Okay. Problem number 3, question 5 of exercise 20D. A solid rectangular block of metal 49 cm by 44 cm by 18 cm is melted and formed into a solid sphere. Calculate the radius of the sphere. We have a rectangular block. This rectangular block is converted by melting into a sphere, into a solid sphere. Dimensions of the rectangular block are given, which are 49 centimeter by 44 centimeter by 18 centimeter. We need to find the radius of the solid sphere which is formed. In this case, again, the volume will remain same. Volume of the rectangular block will be equal to volume of solid sphere that is formed. Okay. Volume of rectangular block is equal to volume of solid sphere. Okay. Now, how to find the volume of a rectangular block? This rectangular block is a cuboid. We know, we have studied how to find the volume of a cuboid. What is volume of cuboid? Volume of cuboid. In this case, a rectangular block. It is very easy. Just we have to multiply the length, breadth and height. Equal to length into breadth into height. Here 49 into 44 into 18. Okay. What about the volume of sphere? We have volume of solid sphere is equal to 4 by 3 pi r cube. Okay. We are taking r as a radius. Let's find the value of r. Since both these are equal, we can equate them. 49 into 44 into 18 is equal to 4 by 3 pi 22 divided by 7 into r cube. Here you have to give the value 22 by 7 because there is nothing to cancel. To find the volume of cuboid, you don't need pi there. Okay. What is r cube? R cube will be equal to 49 into 44 into 18. 3 taken to the opposite side, 7 taken to the opposite side. There it becomes multiplication. 3 into 7 divided by 4 into 22. Okay. 22, 44 can be cancelled. We get 2 here. 2 and 4. Again 2. 2 and 18. 9. So on multiplying 49 into 9 into 3 into 7, you will be getting 9261. Okay. 9261 is the value of r cube. We need r, which is the cube root of 9261. When you do the calculation, you will be getting 21 centimeter. Okay. Cube root of 9261 is equal to 21. 21 centimeter is the required radius of the solid sphere which is formed. Radius of solid sphere is equal to 21 centimeters. Okay. Easy, right? Again, the same steps we have followed. In these cases where there is a conversion of solids, we'll be taking the volume. Clear? Problem number 4, question 7 of exercise 20D. A hemispherical bowl of diameter 7.2 cm is filled completely with chocolate sauce. This sauce is poured into an inverted cone of radius 4.8 cm. Find the height of the cone if it is completely filled. Okay. From a hemispherical bowl, the sauce, the chocolate sauce is poured into a inverted cone, which means the volume of hemispherical bowl should be equal to the volume of cone, because the chocolate sauce is completely filled in the hemispherical bowl as well as in the cone. Okay, so we are having volume of hemispherical bowl is equal to volume of cone. Okay. A hemispherical bowl of diameter is given 7.2 centimeter. Half of 7.2 centimeter is 3.6 centimeter. Therefore, 3.6 centimeter is the radius. Okay. Then, what about the cone? The cone radius is given, which is 4.8 centimeter. 4.8 centimeter. We need to find the height. Volume of hemisphere. What is the volume of hemisphere? Volume of hemisphere is equal to 2 by 3 pi r cube. 3.6 cube. Okay. Then volume of cone is equal to 1 by 3 pi r square h. That is 1 by 3 pi r square. 4.8 square into h. Here we don't need to put the pi value, which can be easily cancelled. Equating, we get 2 by 3 pi 3.6 cube is equal to 1 by 3 pi 4.8 square into h. h is the height of cone which we need to determine. Pi can be cancelled. 3 which is there in the denominator can be cancelled. Then we have h is equal to 2 into 3.6 into 3.6 into 3.6 divided by 4.8 into 4.8. Okay. In order to remove the decimal, here we have 3 decimals to be removed. I am multiplying numerator and denominator by 1000. Okay. So that 3 decimals can be removed from the numerator. You get 2 into 36 into 36 into 36 divided by 48 into 48 into 10. Okay. 12 into 3 is 36. 12 into 4 is 48. So here we get 3, 4. Here again 3, 4. Then 4 4s are 16. 16. Here we have 2 and 36. 4 and 36 can be cancelled. We get 9 here. Then this 4 and 2 can be cancelled. We get 2 here. 9 into 9. 3 into 3, 9. 9 into 9 is 81. 81 divided by 2 into 10, which is 20. 81 by 20. 81 by 2 will be getting 40.5. 40.5 divided by 10, and that is 4.05 centimeter. So 4.05 centimeter is the height of cone, okay, in which the source is filled. Clear? Height of cone is equal to 4.05 centimeters. Understood? Let's move on to the next problem. Problem number 5, question 10 of exercise 20D. A solid metallic cone with radius 6 cm and height 10 cm is made of some heavy metal A. In order to reduce its weight, a conical hole is made in the cone as shown and it is completely filled with a lighter metal B. The conical hole has a diameter of 6 cm and depth 4 cm. Calculate the ratio of volume of metal A to the volume of metal B in the solid. Okay, here we have a cone. In order to reduce its weight, a hole is made which is in the shape of a cone. Okay, and this portion is filled with metal B. Now, when this portion is filled with metal B, only the shaded region here is filled with metal A. We need to find the ratio of volume of metal A to the volume of metal B in the solid. Okay. First, let us find the volume of whole cone. Volume of whole cone is equal to 1 by 3 pi r square h. That is 1 by 3 pi r square. Here the radius is 6 cm. 6 square into height, which is 10 cm. 10 equal to pi into 6 into 6 into 10 divided by 3. 3 and 6 can be cancelled. We get 2. 2 into 6, 12. 12 into 10, 120. 120 pi. Okay, so the volume of whole cone is equal to 120 pi. Now, the volume of cone with metal B is equal to 1 by 3 pi r square h, 1 by 3 pi. Here the radius is not given. Instead, the diameter is 6 cm. If diameter is 6 cm, we know radius will be equal to 3 cm into 3 square into height, which is the depth given 4 cm into 4. Okay, 3 and 3 square. 1 3 can be removed. Then you will be having 3 into 4, 12, which is 12 pi. Now, we need to find the volume of cone with metal A. That is the shaded portion. How to get? We need to subtract the volume of the cone with metal B from the volume of the entire cone. Okay. Volume of cone with metal A is equal to volume of whole cone minus volume of cone with metal B. Put the values. Volume of whole cone is 120 pi minus volume of cone with metal B, that is 12 pi. 120 pi minus 12 pi, you will be getting 108 pi. Now we can find the ratio. Volume of cone with metal A divided by volume of cone with metal B is equal to 108 pi divided by 12 pi. Pi and pi gets cancelled. 3 into 4 is 12. 3 into 36 is 108. 36 by 4 is equal to 9 divided by 1 and the required ratio is 9:1. Okay, so 9:1 is the ratio of volume of cone with metal A to the volume of cone with metal B. Clear? Now let's solve problems from exercise 20E. Here we have the first problem. Question 4 of exercise 20E. This is related to the combination of solids. A cubical block of side 7 cm is surrounded by a hemisphere of the largest size. Find the surface area of the resulting solids. We have a cubical box. Okay. Then it is surrounded by a hemisphere of largest size. Hemisphere of largest size, which means the circumference of the base of the hemisphere should touch all the sides of the square which is coming on the top of the cube. Okay, so this is how the hemisphere would be. Now, it is given that the side of cubical block is 7 centimeter. Okay, this 7 centimeter will be the diameter of the hemisphere. Okay, diameter of hemisphere is equal to side of cube, and that is 7 centimeter. So we'll be having radius of hemisphere equal to 7 divided by 2 centimeter. 7 by 2 centimeter. Now we need to find the surface area of resulting solid. To get the surface area, just look at here. We have 6 faces for the cube. You should exclude the top face because there you have a hemisphere coming. You have the base and the 4 faces, side faces. So 5 faces of the cube, then the curved surface area of hemisphere. One more region is there, which is this part. The part of the top face of cube that is not included within the hemisphere, which means to get that portion, we need to subtract the surface area. We need to subtract the area of base from the top face. Clear? Okay, so let's first find the curved surface area of hemisphere. Curved surface area of hemisphere is equal to 2 pi r square, which is 2 into 22 divided by 7 into r square. Here radius is 7 by 2. 7 by 2 into 7 by 2. Cancelling 2 and 2, 7, 7. 2 and 22, we get 11, which is 77 centimeter square. Okay, 77 centimeter square is the curved surface area of hemisphere. Then we need to find the area of this portion, which is area of portion of top face of cube excluding the base of hemisphere will be equal to, here this is a square. What is the area of square? Side into side. 7 into 7 minus, this is a circle, base of a hemisphere we know it is a circle. How to find the area of circle? Pi r square. Pi r square, and the radius is 7 by 2 whole square. That is 7 into 7, 49 minus 22 divided by 7 into 7 by 2 into 7 by 2. 7, 7 gets cancelled. 2 and 22 we get 11. That is 49 minus 77 divided by 2, which is equal to 98 minus 77 divided by 2, 21 by 2 or 10.5 centimeter square. So area of this shaded portion will be equal to 10.5 centimeter square. Next we need to find the area of the remaining 5 faces. Okay, therefore remaining area of cube will be equal to 5 into side square, that is 5 into 7 square, 5 into 49, and that is equal to 245 centimeter square. Okay, 245 centimeter square. So the total resulting surface area, total resulting area will be the sum of all these three. That is the curved surface area of hemisphere, then the shaded portion and the area of 5 faces of the cube. Okay, put the values. Here we have 77 centimeter square plus 10.5 plus 245. That is equal to 332.5 centimeter square. On adding this, you will be getting 332.5 centimeter square. Clear? So this is how you can find. Okay. This is an example for combination of solid. Here we have combined a cube and a hemisphere and we are finding the surface area. Okay. Problem number 7, question 5 of exercise 20E. A vessel is in the form of an inverted cone. Its height is 8 centimeter and the radius of its top, which is open, is 5 centimeter. It is filled with water up to the rim. When lead shots, each of which is a sphere of radius 0.5 centimeter, are dropped into the vessel, 1/4 of the water flows out. Find the number of lead shots dropped in the vessel. Here we have a conical vessel which is filled with water up to the rim. Okay. Now, small lead shots are added to this. Then what happens? Since the water is filled up to the rim, when the lead shots are added to it, water will flow out. Okay. The water that flows out is given 1/4 of the volume of water that was there inside the cone. Okay. It will be equal to the number of lead shots into the volume of each lead shots, because the amount of water that goes out depends on the lead shots volume and the number of lead shots. Okay. So we'll be having volume of water that flows out equal to number of lead shots into volume of each lead shot. Okay. First, let us find what the volume of the cone is. Volume of cone is equal to 1/3 pi r square h. R square h, that is 1/3 pi. Here the radius is 5 centimeter. 5 square and height is 8 centimeter into 8. Okay. Given that 1/4 of this water flows out. So volume of water that flows out is equal to 1/4 this volume. Yes, 1/4 the volume of water in the cone. 1/3 pi into 5 square into 8. Okay. Now, we need the volume of each shot. Volume of each shot will be equal to, each shot is a sphere, therefore 4/3 pi r cube. Here what is the radius of spheres? 4/3 pi into 0.5 cube. Okay. Now we have volume of water that flows out. 1/4 into 1/3 pi into 5 square into 8 is equal to number of lead shots. Let us take the number of lead shots as n into volume of each lead shot. Volume of each lead shot is 4/3 pi 0.5 cube. Okay. Here 3 is there in the denominator. 3 is there in the denominator, which can be cancelled. Pi and pi can be cancelled. Then 4 and 8 can be cancelled. We get 2 here. This 2 and 4 can be cancelled. Again, we'll be getting 2. Now, we have n is equal to 5 square, 5 into 5 divided by 2 into 0.5 into 0.5 into 0.5. Okay. 0.5 cube is 0.5 into 0.5 into 0.5. 0.5 into 10 is 5. Yes. So here we'll be getting a 10. Again 0.5 into 10 is 5. So 10 into 10, that is 100, divided by 0.5 into 2 is equal to 1. So the required answer is 100. 100 lead shots are put into the cone so that 1/4 of its water flows out. Okay. So the number of lead shots is equal to 100. Clear? Understood? Is this calculation clear? We have 0.5 into 10 is equal to 5. Okay. If you want, you can put the decimals. That is, you can remove the decimals by multiplying with 100 on the numerator and denominator. Okay. Next, problem number 8. Question 7 of exercise 20E. Find the maximum volume of a cone that can be carved out of a solid hemisphere of radius r centimeter. We have a solid hemisphere whose radius is r centimeter. So from this we can carve out many cones, right? Like this is a cone, this is a cone, this is a cone. Now what we have to find? We have to find the maximum volume of a cone that can be carved out. Maximum volume means up to the base we can go, right? So this is the maximum volume of cone. All these cones are smaller than the cone which I drew last. Yes. So for this cone, we need to find the volume. How to find the volume? Now what is the height of this cone? Here, for this hemisphere, this distance, what is this distance? This distance is the height of cone. Also, this distance is the radius of hemisphere. Yes, when you have a hemisphere, this distance will be the radius of the hemisphere. This is also a radius. Okay, so when you carve out a cone from the hemisphere, the maximum height is when the height of cone is equal to the radius of hemisphere. Height of cone equal to h is equal to radius of hemisphere. Okay. What is the volume of a cone? We have volume of cone is equal to 1/3 pi r square h. Okay. Here the height is radius of hemisphere. Therefore, we'll be having the volume of cone, which is the maximum volume of the cone which can be carved out from the hemisphere is equal to 1/3 pi r square into, in place of h, we can put the radius value. That is r. We have 1/3 pi r cube. So 1/3 pi r cube is the maximum volume of a cone that can be carved out from a hemisphere. Clear? Here we have the last problem for today. Problem 9, question 8 of exercise 20E. The radii of bases of two solid right circular cones of a same height are R1 and R2 respectively. The cones are melted and recast into a solid sphere of radius capital R. Find the height of each cone in terms of R1, R2 and R. We have two cones, each of height h and radius R1 and R2. Okay, so these two cones are melted and recast into a sphere of radius capital R. So when you take the volumes of both these cones and add, we'll be getting the volume of the sphere which is formed. Okay. Now, volume of first cone with radius R1 is equal to 1 by 3 pi R1 square h. We have taken h as the height of cone. We need to find what the height of cone is. Then, volume of second cone with radius R2 is equal to 1 by 3 pi R2 square h. Okay, both these are added when melted and they are recast into a new sphere. We need to find the volume of sphere. Volume of sphere. What is the volume of sphere? 4 by 3 pi r cube. Here the radius is capital R, therefore capital R cube. Volume of sphere will be equal to volume of cone with radius R1 plus volume of cone with radius R2. What is the volume of sphere? Volume of sphere is 4 by 3 pi r cube equal to 1 by 3 pi r1 square h plus 1 by 3 pi r2 square h. Now, in both these we have 1 by 3 pi h common. Taking out, we get 1 by 3 pi h into r1 square plus r2 square is equal to 4 by 3 pi r cube. Okay, pi and pi can be cancelled from both sides. This 3 and this 3 can be cancelled. We'll be having h is equal to, left hand side we have 4r cube divided by, taking these terms to the denominator, that is r1 square plus r2 square. The required height of cones will be 4r cube divided by r1 square plus r2 square. Here we are asked to find the height in terms of r1, r2 and capital R. We have height in terms of capital R, r1 and r2. Okay, that's all for today. In today's class, we have discussed the conversion of solids and combinations of solids. We have solved many examples and questions from exercise 20E and 20D. Hope you all enjoyed the session. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.